So last class we have discussed about, that is, when the time is constant for the wave, we got the equation, that is y equal to a sine kx. Okay, this is for when the time is constant. When the displacement is constant, then the equation of wave is a sine omega t. This is for when the x is constant. Okay, if both of them are variable, then the equation will become a sine kx minus of omega t. Okay, how this is kx minus of omega t? Let's discuss. So now let me take the diagram from here. Okay, and let's say if the particle is present at this position, okay, by making an angle, and if this is the displacement made in the x-axis, okay, this is the displacement that it has made, x. Okay, so if the particle will come here, okay, so definitely the displacement will increase, or the distance traveled by the wave will increase. Previously the distance was like this. Okay, now the distance is this much, but now see the angle. When the particle is coming from this point to this point, you can see the angle is decreasing, because previously the angle is this much, that is kx. Okay, let's say this is kx. Okay, now the angle is coming back to here. When the particle is coming here, the angle is decreased to this much. Okay, and for the last calculation, the angle is omega t always, right? So previously, as the displacement has made x, okay, so the particle has reached from this point to this point, right? Right, at this point the angle made was kx, right? Now at this point, when it is reaching here, okay, now if we will calculate, okay, now this angle is omega t, right? So what should be this angle? If the full angle, this full angle is kx, the small angle is omega t, then what should be this angle? This angle is kx minus omega t, right? Again, if the full angle, this is the full angle, okay, this is the full angle, this full angle is kx, this angle is omega t, okay, then what is the proper angle that is being made by the particle when it is being displaced clockwise? Okay, when this particle is traveling in the clockwise direction, what is this angle is about? This angle is kx minus omega t. Okay, at this stage it will become kx minus omega t. Okay, if it is a clockwise rotation like this. Okay, if the wave is traveling from left to right, you will always achieve this one. Okay, next, if the suppose the wave is here previously, okay, this one is here, the particle is here, okay, the displacement is this one, okay, and the distance traveled, suppose it is x. But if the particle will, okay, and this angle, let's say kx, right, and if this particle is going to this point, okay, by making an angle omega t, okay, then you can see here, this is the reverse case we are going to observe. Okay, now what will happen? Previously the distance was like this, okay, this is the distance. Now the distance is decreased, but your angle is increased. Okay, what you can say, your angle is increased. Okay, when the particle is moving from this point to this point, okay, in anti-clockwise direction, when it is moving like this, your angle is increasing. Okay, your angle is increasing. Okay, but what is decreasing? Your displacement over the distance traveled. Okay, in the x-axis, okay, this one is decreasing. Okay, the x is decreasing, right? So here again, what I can say, if this angle is kx, okay, this one is kx, okay, and the next angle is omega t, okay, this to this is omega t. Okay, then what should be the full angle? Kx plus of omega t, right? So what should be the formula? Y equal to a sine kx plus omega t, right? If it is moving in anti-clockwise direction in this side, okay, this will be kx plus omega t. If it is moving in the clockwise direction, it will be y equal to a sine, okay, kx minus omega t. This is the equation. One thing only you have to remember: if the x will increase, okay, then the angle will decrease, and if the x will decrease, then obviously the angle will increase. Okay, this thing we need to remember, right? And if you will make, or if you will consider the initial phase, if a particle has not started from the mean position, if it has started, because wave can travel from anywhere, it has start from any maximum position. If it has started from any maximum point, okay, from here it has started and it is moving like this, for this kind of thing a initial phase is going to be introduced, because it is already available in the video. What is the initial phase? Plus or minus phi. Okay, so the equation of wave, okay, it should be, generally we are taking from left to right, okay, this kind. Okay, so for left to right we are going to get the equation a sine kx minus omega t plus or minus phi. Okay, the phase will be plus or maybe minus. Okay, so the full equation of the wave is a sine kx minus omega t plus or minus phi, the phase angle phi. Okay, so this is the thing. Now let's move on to the next. The next thing is the speed of wave in different medium. Okay, the speed of wave in different medium, and the velocity of the wave, okay, velocity of the wave propagation is depending on what factor that we need to find. The velocity of the propagation of the wave is depending on what factor that we need to find. See here into this diagram, as you can see this one clearly. Here, to a rigid surface, okay, this is a rigid surface, one string is being attached, okay, through one pulley, right? And it is crossing over a pulley, and after that when weight is being attached here, okay, here if you will attach the weight, okay, then a tension is going to be produced, right? If the tension is going to be produced, and if you will increase the weight, okay, if you will increase the mass, right, if you will increase the mass, then obviously the tension will also increase. If the tension will increase, then if you will pluck here, pluck means you are going to pull this one in downward direction or upward direction in order to create a oscillation. Okay, so if you will oscillate here at this point, if you will pull it and then you will leave this one, you will pull in this direction and you will leave, then obviously and wave will going to travel in this direction, right? So what you will do, you will pluck it here, okay, and you will observe the velocity is higher. Okay, why it is higher? Because the tension is higher, right? Because it attaches tightly. Okay, as the tightness, or you can say as the tension is increasing, backward force is increasing, if you will pluck it here, obviously you are going to achieve a full velocity, or you can say high velocity of wave traveling. Okay, so here you can say tension is directly proportional to the velocity. Now move on to the next thing. What is that? Here let me write it. Tension is directly proportional to velocity. Okay, or simply you can say like this, because we are finding out the velocity relation. Here next is, look at to this string, okay, and let's take the mass per unit length. Okay, mass per unit length as small m, okay, this one. Okay, so mass per unit length is small m in the string. Suppose I will take, okay, suppose let me take a heavy string like this. Okay, let me take a thick wire, okay, of heavy huge mass, okay, of huge mass. If I will pull, okay, general common sense, if I will pull like this wire will take time to reach back or to come back to the original position, right? If I will pull this wire, if this wire is very thick, okay, so obviously if I am going to pull it, okay, if I am going to pull it in this direction, then to come back to the zeroth position or to the mean position, what is the mean position? This is the mean position, okay, this one, the middle one, this middle one is the mean position. To come back to the mean position, obviously it will take the time. Why? Because it's a thick wire, or you having the huge mass. But if you will take the smaller wire, okay, if you will take a very small, or you can say very small mass wire, thin wire, then what is going to happen? If you will pull it, suddenly it will go back to its original position, right? So here you can say what I have taken, mass per unit length, small m, right? So mass per unit length is of the wire is inversely proportional to the velocity, right? Because in the thick wire, okay, the wave traveling is quite slow. The wave traveling is quite slow, but in thin wire, or you can say very small mass wire, obviously the wave propagation is quite faster. Okay, so here I can write it as transverse wave because it's a transverse wave. Obviously, why it is a transverse wave? Because I already told you are making a oscillation when you will pluck it here. Okay, you are making a oscillation in this direction. Okay, and wave is traveling. Wave is traveling in this direction. Both are perpendicular to each other, so that's why it's a transverse wave. So transverse wave on string. Here one tension T is created due to mass mg, and if T will increase, tension will increase, okay, then the string will be pulled backward with more speed. Okay, it will be pulled backward because of the tension, it will be pulled backward, right? And so a more velocity is going to be produced when you will pluck it. Okay, right? That is, T is directly proportional to the V, as I have discussed. But if I will take the mass, okay, mass per unit length of the wire, okay, I'm talking about the wire, m equal to mass of wire per unit length, right? But if mass m will increase, then it will decrease the speed of the wave, right? So the formula I can write it as V is inversely proportional to m. One is what? V is directly proportional to T. Another one is V is inversely proportional to m, and the final expression is V equal to root over of T by m. This root is because of dimensional analysis. Okay, this dimensional analysis we have done it in the first year. Okay, and because of that, somewhere we are getting square, somewhere we are getting root. Okay, that is because of the dimensional analysis. So the final formula of the V is root over of T upon m, right? Now let's see upon what is that, what will happen on the longitudinal wave. Okay, longitudinal wave, how you can produce a longitudinal wave. If suppose this is a box is present, okay, or any heavy metal is present, you want to produce a longitudinal wave. So what you will do, you have to hit the hammer in this direction, okay, then these particles will, okay, compress, okay, expand like this, okay, and will reach it here. The wave will travel in this direction, okay, and the wave will not travel like this. Okay, this wave will not travel like this. I already told you what is longitudinal wave. If the oscillation direction, this is the you are hitting the hammer in this direction, so the oscillation will take place like this, okay, like this, okay, like this. Okay, the oscillation is in this direction. The wave is also due to compression, okay, continuous compression, is traveling from left to right, okay, from left to right, right? So this kind of case is obviously a longitudinal case. Okay, I already discussed this one. Okay, so for longitudinal wave, okay, the velocity of the wave is directly proportional to the elasticity coefficient, okay, or modulus of elasticity, or simply you can say it depends on the how much pressure we are creating in that longitudinal case, right? If it is a we are considering this wire and we are considering a longitudinal wave traveling case, right? Then obviously the velocity is depending on how much pressure that we are applying, okay, and what is the elasticity in that material, okay, elasticity, modulus of elasticity in that material. So if I will increase this one in this direction, then how much it has the willpower, okay, or how much it is having the intention to go back, right? So this is depending on that, okay. So velocity is obviously depending on how much elastic or how much pressure is going to be produced in that particular material, right? So pressure means applied force upon area. So V is directly proportional to force upon area, okay, right? But obviously in the last of this explanation, what we have observed, the velocity is obviously going to inversely proportional to the mass, okay. But as it is a thick object, that case we are considering a wire, okay. But in this case, okay, last case we have considered about a wire. As you have seen, a wire was there and a mass mg was attached. And in this case, as we are considering the thicker object, right, so what we have to take, not mass per unit length, we have to take mass per unit volume, right? M upon V, okay. So what should be the expression? V is directly proportional to force upon area divided by mass per unit length, because velocity is inversely proportional to mass per unit volume, right? And mass per unit volume is known as what? Density, okay. Mass per unit volume is known as density, okay. So I can write it this expression as change in pressure, right? Change in pressure or elastic coefficient, because velocity is directly proportional to change in pressure, okay. How much it should be? That is F upon A whole divided by your density, okay. What should be the density? The density is rho, okay. Now for the solids, generally we are taking what? Young's modulus. So for solids, elastic coefficient is what? Y. So V formula will become, V formula is what? Root over of something, right? Tension upon mass, like this. This is the formula, general formula. So this formula is also V equal to root over of Young's modulus divided by rho, okay, density, right? Y upon rho. And if for gases, generally bulky properties, okay, what we are going to have, for the volume we are going to consider, and it should be of the bulk modulus. There we have to consider the bulk modulus. So this will be V equal to root over of B upon rho, okay, bulk modulus upon density, okay, because V is directly proportional to what? Modulus of elasticity. Modulus may be your Y or maybe B or whatever it may be, right? And obviously it should be divided with density. Density is what? Mass per unit volume or mass per unit, okay. That case we have to take the density. Next we are going to start the superposition of the wave, okay. For superposition, I can tell you one simple example. If one particle is here, right, and when wave is coming in this direction, okay, and when the crest will come to this particle's point, obviously it is going to lift up to some height y1, okay. If another similar kind of wave will also come, okay, after some time, okay, similar wave, okay, same frequency, same direction, it will also take it to the same height as that of y1, because the wave is same, particle is same, okay, and the displacement made is y1, okay, as that of y1. This is same, y1 and y2 both are same, okay. How much amplitude are both of them are going to produce? Same amplitude. But if both of them will come together, okay, both of them will come together, and how much they are going to displace this particle? Obviously this should be y1 plus of y2, because single one was doing how much displacement? Y1 displacement, okay. Second one is doing how much displacement? Y2. So what is the total displacement made? Y equal to y1 plus of y2. So in this case, your amplitude, okay, because we are taking the positive half, right? The positive cycle only, because crest is what? Positive amplitude. Okay, so positive plus a and plus a. Okay, the answer is 2a. Okay, so superposition means simple addition. The word indicates superposition means simple summation. Okay, so let me read this one. Suppose one particle is in air. This is the particle. Two same waves are coming from same direction. They both will lift the particle to a same amplitude. If they come simultaneously or same time, if they will come at the same time, they will lift the particle somewhat higher, that is double. Okay, so the formula is what? Y1 plus of y2. Okay, y1 plus of y2, that is a plus a equal to 2a. Very simple and very easy. Okay, if you want to represent this one in the vector form, this will be y vector is equal to y1 plus of y2. Okay, now let me see what are the features. Okay, let us see what are the features. Next, if a source is present here, okay, and it is producing a wave, let me make a broader diagram like this. Okay, here various sources are present, source 1, source 2, source 3, like this, and from single sources so many waves are going to be created. Okay, suppose here the wave is created like this, one wave, okay, and another wave is also creating like this. And let's see here closely at this particle. Okay, what is coming here? One is, this one is what? This structure is obviously crest. Okay, and this structure is obviously a trough. You can see it clearly, closely you can observe here. Here one crest is present like this. Okay, here is one trough. Okay, so crest is having a value how much? Plus a. Okay, trough is having a value how much? Minus a. So how much displacement they will make to this particle, or what will they will create a effect to this particle? This is plus a minus a. The answer is 0. Nothing is going to be produced in that particular point. Okay, they are not going to disturb this one. Okay, so what will happen here? Simply a cancellation. Crest and trough, the result is a cancellation. Next, for an example, this particle is here, okay, and from the another source, okay, the waves are coming like this, okay, like this, and here you can observe near the particle two crests are being reached. Okay, this is a structure, you can see crest, this is also a crest. So crest plus of crest, what is that? A plus of a, the result is 2a. Right, so various sources are there like this. Okay, so where somewhere it is producing 0, you can see here. Okay, I have drawn for the two sources, and other sources are also present. Okay, like this it is producing what? Somewhat it is producing a amplitude 0, somewhere it is producing a higher amplitude 2a, means where the sound, somewhere the sound is less, somewhere it is increasing. Okay, somewhere it is decreasing. Okay, somewhere again it is increasing, somewhere decreasing. This is what is known as interference. Okay, this is known as interference. Okay, because we are getting a result unexpected. Okay, crest and trough making amplitude 0, two crest making 2a, two trough will make minus 2a, like this. Okay, so here first feature is your interference. What is the interference? Interference is two waves having the same frequency and moving in the same direction. Okay, so if the two waves are going, okay, then obviously they are going to interfere, right? So if one crest and one trough will come, then both the amplitude will be neglected in the first case, so the amplitude is 0. If two crests will hit, then we will get double of the amplitude. Okay, and the particle will be obviously lifted, and this A equal to 0, 2A, 0, 2A like this is called as the interference. Okay, all of you understood up to this? Switch on your mic, everybody, and say me yes if you understood.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Okay, so now let's move on. What is a beats? Okay, beats is what? If the frequency is somewhat different, but the direction is same. Okay, this is known as the beat. Okay, this is what? Frequency slightly different. Okay, but direction is same. Okay, this is known as the beat. Frequency slightly different means, suppose the wave is going like this, first wave, the second wave is going like this. Okay, here you can say it is moving faster, or it is completing its cycle faster. Okay, in the second case. Okay, so that's why you can say frequency is slightly different, but the direction is same. And the mixture, if you will mix it, okay, obviously it will produce a loud sound. Okay, why it is a loud sound? Okay, why it is a loud sound? Because obviously, as there is an interference, one slow frequency sound and plus of one severely repeating frequency sound, they will, if they will add it up, obviously they are going to produce a loud sound. Okay, now next thing is what? A stationary wave. Okay, what is a stationary wave? See, one very beautiful example I'm going to give you. All of you have went through your sea beach, right? So when you are going to the sea beach, the water is coming like this. Okay, you are standing with your feet like this in the sea beach. Okay, the water waves are coming like this and crossing your feet and going back in this direction, and again they will return. Okay, and they will again return. Okay, in which direction? In this direction, right? They will return from the back side towards the front side. So when they are returning, at that time another wave is also coming like this. Okay, so I can say, give you this figure somewhere like this. Okay, let's say this wave is returning. Okay, and at that time, okay, another wave is coming in this direction. Okay, what will happen? There will be a collision. Okay, so if there will be collision in this side, you might have observed, if the waters are returning from this side, okay, and another wave is coming in this direction, and near your feet you can observe, okay, no wave. Okay, you can feel no wave is crossing through your feet. Only you can see, observe that a vibration is taking place and some foam is being created. Okay, because of the disturbance, you can see no wave is going to travel to means by crossing your feet. No waves will travel by crossing your feet as the previous case, because in the first case, when you were standing, the waves came, the first wave came and just crossed your feet. Okay, this is a complete wave propagation. But when it was returning, okay, when this wave was returning from this direction, obviously it will return and will move back towards the sea. And at that time, if another wave will come, okay, at that time what will happen? Due to the collision, you will observe a vibration, as well as you can observe a foam is being, due to the vibration, a foam is being created near your feet. Okay, this is a simple example of your stationary wave. Okay, here you can say waves coming in opposite direction with the same frequency. Okay, what is a stationary wave? Waves coming from the opposite direction with the same frequency. Example is this one: when the sea waves are coming in opposite direction, they will collide. The result is only vibration at the middle. Okay, you can do it in the artificial manner also. Take a string, okay, and fix it in both the side. Okay, like this way you can do it. This is a string, like, okay, this is a rigid surface in both the side. Attach a flexible material here, flexible wire, and pluck it at the middle. Okay, pluck means just disturb at the middle, pull it down, and then leave it. You can observe here, no wave is going to produce, only a vibration like this. Okay, there will be a vibration like this, or you can see there will be a vibration like this, vibrating. Okay, so this is known as the formation of the stationary wave. Okay, here you can say what is happening in the C case. In the C case, one wave is traveling like this, another wave is coming like this, okay, in this direction. So there will be a disturbance in the middle, okay. And obviously you are going to write down the equation. What will the equation for the displacement y equal to formula for wave formula? One formula is your y1 plus of y2. If this is y1, okay, this is y2. As this is flowing from left to right, okay, left to right, it should be of the plus kx plus omega t. As you can see here in the equation, this should be addition y equal to y1 plus of y2. So y equal to the first one, as it is moving from left to right, okay, this should be your a sine kx plus omega t, okay. Another one is from coming from right to left, right, this should be your kx minus omega t, or you can change it because this a plus symbol is there, so no need to create any issue. So always remember, if a wave is traveling from right to left, okay, from right side to left side, the formula is kx plus omega t. Always remember, okay. And if the wave is traveling in the opposite, that is like this, left to right, it will be kx minus of omega t. This is the general equation, okay. Next, we are going to add it, a sine kx plus omega t plus a sine kx minus omega t, okay. Next, how can I will solve it? This is sine a plus b and sine a minus b. Simply I will do one thing, sine this one plus I will take c, and this kx minus omega t I will take it as d. Okay, what is the formula for sine c plus sine d? The formula for sine c plus sine d is 2 sine c plus d by 2, okay, multiplied with cos c minus d by 2. Sine c plus d is 2 sine c plus d by 2 multiplied with cos c minus d by 2. Okay, just place it. Let's going to in the next step we are going to place it, the 2a common, sine c plus d by 2 multiplied with cos c plus d by 2. C is kx plus omega t and d is kx minus omega t, right? And here you can observe that 2a into sine kx into cos omega t, okay. And the final expression you will achieve as 2a, because 2a is 2a multiplied with sine kx into cos omega t, and this is known as the equation of stationary wave, okay. Now this is all about the disturbance that is going to be produced. In the next class we are going to read the Doppler's effect, okay, in the next class. So